Hi guys, this is Mrs. Bucher. This video is over application problems, so basically word problems. Okay, first problem. The number of songs that can be stored on an MP3 player varies inversely with the average size of a song. A certain MP3 player can store 2,500 songs when the average size of a song is 4 megabytes. Write a model that gives the number n of songs that will fit on the MP3 player as a function of the average song size S. How many songs will fit if the average size of a song is 2.5 megabytes? I see a typo. Let me fix it. There. Alright, so we have variables. We have the number of songs that can be stored on the MP3 player, which we're going to use the n. Whoa. That's better. Varies inversely, so we're going to say equals the constant divided by the average size of the song, which we're going to use an S. So there's the setup. It says the certain MP3 player can store 2,500 songs when the average size of a song is 4 megabytes, so we're going to put 2,500 in for the number of songs equals the constant divided by the size of 4. And then when you multiply 4 times 2,500, we get a K value of 10,000. That's your constant. So it says write a model that gives the number n of songs as a function. So 10 equals 10,000 over S. Basically saying your MP3 player can hold 10,000 megabytes, and then you have to divide that up into how many megabytes per song. Alright, so then it says how many songs will fit if the average size of a song is 2.5 megabytes. So now we just say the number of songs would be 10,000 divided by 2.5. And when you punch that in your calculator, you're going to get 4,000 songs. Something to think about here. Suppose I'd gotten 4,000.2 or even 0.7. Your MP3 player cannot hold a partial song, and if all it has room for is a partial song, it's not going to download the song at all. So even if it was 4,000.9, you can't round up to 4,001 because there's not room for it. So you always, in this case, have to round down to the lowest whole number before it, so 4,000. Next problem. The time it takes a parade to pass a building varies directly with the length and inversely with the speed of the parade. That means that the longer it is, the longer it's going to take, but the faster they're walking, the shorter it's going to take. So that goes all together in one equation. A parade 500 feet long, walking 1.2 miles per hour, needs 4.64 minutes to pass the building. Find the value of the constant K. How long will it take an 800-foot-long parade walking 0.7 miles per hour to pass the building? Alright, now I'm going to pause right here. If you're watching this video and you printed out the notes and you're just following along, that's fine. But I have a way this time. I want to make sure that you actually watch the video. At the bottom of your notes, I want you to draw a little picture of a parade passing a building. And some of you are excellent artists, and some of you can not draw very well at all, and I don't care. You can make little stick figures on a float or blowing trumpets or whatever, but I want to see a drawing of a parade at the bottom of your printed out notes if you printed them out. All right, going on. So the time it takes the parade to pass the building, it doesn't say what variable to use. Let's use a t. Equals, because varies, directly with the length, so K times L, and inversely, so also divided by the speed. A parade 500 feet long, walking 1.2 miles per hour, needs a time of 4.64 minutes, so 4.64 equals K times the length of 500 divided by the speed of 1.2. So we're going to multiply 4.64 by 1.2 and then divide that answer by 500 to get a constant of 0.011136. And I didn't cut off any of the decimals here. I didn't round, because if I round in the middle of a problem, it is going to ruin the answer. So you keep all of it. And then we're going to use this model we didn't have to write the model, it just said find the value of the constant. So there's part 1. Then it said how long will it take, so we want to know the time. And we go 0.011136 times the length, which would be an 800-foot parade, walking 0.7 miles per hour. So now you can push that into the calculator, and you will get a time of 12.727, and now you can round minutes. 12.727 minutes. So 800 is longer than 500, but it's taking them more than twice as long because they're walking slower. Alright, last example. Mrs. Bucher buys a Keurig coffee maker for $180. And here's a picture of the one I have at home. K-cups cost 80 cents each. A K-cup is these little cups here. They're like little pods of coffee, and you just pop one in right there, and it makes you a cup of coffee. And then all you have to do to clean up is throw it away. It's fabulous. Alright, anyway, write an equation that gives her average cost C per cup of coffee X. So it sounds expensive because $180 is a lot of money for a coffee maker. And then even 80 cents per cup, that's kind of expensive too. But, you know, that's okay. We're going to do this math to figure out if it's worth it. So the equation that gives my average cost per cup of coffee. So you're like, well, it's 80 cents. But it's not because I spent $180 on that coffee maker. So my first cup of coffee cost me $180 plus 80 cents times however many cups I have. So $180.80 for my first cup. When we do average, think about how you average your grades. You add them all up and then you divide by how many there are. So if I'm going to find the average cost, I'm going to add up the total cost and then divide it by however many cups there are. So that's my average cost. You just do it just like if you were setting up a linear equation with your constant plus your rate of change times your variable. It's just that we're going to divide the whole thing by however many, in this case, cups, or however many things there are. Because when you see average, you know that it's going to become a big division problem, which goes along with our chapter. Okay. So now I want to know, what is the horizontal asymptote of this function, and what does it represent? So we know it's a rational function, which has an asymptote, and we want to know why, and what does it mean? So remember, when you were looking for the horizontal asymptote, you're looking for a Dolly Parton or J-Lo, and we look at the x's here. Ooh, didn't mean to do that. And we've got a linear on top and a linear on bottom. So remember, when they're the same degree, you take the ratio y equals, and then the coefficient on this one is 0.8, and then you divide it by the coefficient. So we're on this one, which is 1, so 0.8 divided by 1 is just 0.8. A horizontal asymptote is y equals 0.8. And what does that represent? If you graph the graph, it's going to look like this, with a vertical asymptote at 0 and a horizontal asymptote at 0.8. But we don't care about the negatives because I'm not drinking negative cups of coffee. That wouldn't taste very good. So it's starting here. If I don't buy any coffee, I don't spend any money. So that's why there's an asymptote there. And then the first cup of coffee, this would actually just be points because we're doing specific cups. But this is what the smooth function would look like. As the amount of coffee that I drink increases, the price per cup decreases because that $180 that I initially spent is getting spread out over the amount of cups. But it's going to approach an asymptote at 0.8, and it's never going to go below that. So what does that represent? That represents the actual cost per cup. That's that 80 cents per cup. Because no matter what, I can't go below 80 cents per cup unless, you know, they start charging less for the K-cups, which they probably won't. So that's what it represents. It's y equals 0.8, and it represents the cost per cup. Okay, same question, but now Starbucks charges $2 for a grande cup of coffee. After how many cups will Mrs. Bucher break even? So we're going to take our average value equation that we came up with, the cost per cup, 180 plus 0.8x all over x. And we want to know, when is that cup going to equal $2? So we'll just plug a 2 in for C. So now all we have to do is multiply both sides by x. We get 180 plus 0.8x equals 2x. Subtract 0.8 from both sides. 2 minus 0.8 would be 1.2. And then 180 divided by 1.2 is 150 cups of coffee. That's a lot of coffee. So I don't know, is this thing worth it? So if Mrs. and Mr. Bucher normally drink 2 cups of coffee each per day, after how many days will the Keurig become a worthwhile investment? So we already know that it's 150 cups in order for them to break even. Well, if he and I each drink 2 cups of coffee per day, that's 4 cups of coffee drank per day. And 150 divided by 4 is 37.5. So in 37.5 days, it'll start paying for itself. And we've had it for a lot longer than 37.5 days, so was it a good investment? Absolutely. All right, and that's the end of my little coffee story and our application problems and our half of the chapter. We're going to have a quiz tomorrow, and then we'll be taking the test coming up. All right, y'all have a good night.